Okay, so we have a physics problem in which we are asked to match impact times. One object is given an initial velocity, and you will give a second object an initial velocity such that both objects will hit the ground at the same time. So imagine you're at the top of a building 70 meters high. Your friend throws an object downwards with an initial velocity. You wait for the object to travel 3 meters before throwing your object down. What initial velocity must you give your object in order for it to hit the ground at the same time as your friend's? So what we're going to do is we're going to set up our diagram. Here we go. This little cross just lets me know that's pretty much where my x and y axis is. It's 70 meters high. I save that to the letter in my calculator. That's v subscript 0f. That lets me know the initial velocity that your friend gave his object, and it's in the negative direction, therefore it's a negative velocity. You throw your object when his object has fallen 3 meters, or is at the 67 meter mark. Okay, so the first thing we want to do is we want to solve this for the total time it takes for your friend's object to hit the ground. We're going to set yf equal to 0, write the rest of the distance equation out. Substituting the values, we're going to get a quadratic equation. We're going to solve that, and it's going to give us 3.48 seconds. So keep in mind that y0 is positive 70. VO is negative 3.0 meters per second. And G is negative 9.81. Okay, so even though I have plus there, it doesn't mean that those values are going to be positive. Okay, so the next thing we want to do is we want to solve for the time it takes for the rock to fall through 3 meters. Doing that, we're going to set y1 equal to 67 meters. Then we're going to write the distance equation. y0 is still 70, VO is still negative 3, G is still negative 9.81. Substituting those values in for the variables and using the quadratic equation formula, we find that it takes roughly half a second for the object to fall through 3 meters. The next thing we're going to do is how much time you have to get your object to hit the ground. We're going to do this by subtracting the total time from the time it takes to fall through 3 meters. This gives us 2.95 seconds. That means your object must hit the ground in 2.95 seconds. To find out what initial velocity you must give your object, we are going to set yf equal to 0, y0 equal to 70. VO in this case is unknown. Delta T2 is 2.95 seconds. G is negative. Rearranging this equation and solving for VO. Okay, so there we go. Alright, now keep in mind G is negative, so we have minus half G. That is a double negative, therefore we're going to get a positive. Okay, solving this for VO, we end up with negative 9.25 meters per second. We know we're throwing our object in the negative direction, so this answer fits. You can back check it, but yeah, that's it. Thank you.